Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. We are from Group J, and today we are going to give a group presentation for a group assignment, which is called the thesis summary. Right. Let me have my laser pointer in here. Okay. This is the list of members for Group J, which consists of Muhammad Shakirin, Muhammad Haziq, myself, Muhammad Zul Hakimi, Wan Amirul Khoshari, and Nick Abdul Hadi. Okay. In this kind of presentation, we are going to describe, or we are going to summarize the thesis based on these 9 subtopics or subtopics, which is called subtopics in here. And the first one is the title of the research proposal. Okay, the title is the particulate matter 2.5 predictions using multiple linear regression analysis. Basically, the particulate matter, which is the substance that get into our lungs, which is, you can see in here, PM 2.5 can penetrate deep into the lungs, having serious health consequence for the lungs and heart. While the multiple linear regression, you can see some sort of quick and brief information in here, right? Which is to get the sample data, design a model that work best for the sample, make prediction for the world population, and all of this, right? Okay, for the research problem, as we all know that the air condition, upcoming air condition is at uncertainty. Likewise, this research was held to forecast the upcoming condition of air pollution. In this kind of research, the multiple linear regression method was used, and it is rather than simple regression to estimate the relationship between many independent variables to gain best fitting models. And also, the regression technique had been used since a long time ago to forecast not only these air pollution kind of things, but in any other method or in any other fields. They say multiple linear regression refers to the statistical technique that use 2 or more independent variables to predict the outcome of the dependent variable. And this kind of thing is the technique, and but at least is some sort of information or the technique that being used using the multiple linear regression. And this is also the same thing, right? This in here, some sort of infographic which tells us that air pollution is the silent killer. Air pollution is a major environmental risk to health. And this is also say every year around 7 million of deaths are due to the air pollution. This is some infographic from the WHO, and this is the legit one. Okay, for the formation of the particulate matter 2.5 is complicated as being shared. In the study, correlation analysis was made on the concentration of the thing that consists in the particulate matter, as well as several major air pollutants, concentration, and meteorological elements in the same period. Right. For the research objective, we found that this research is to model the air quality of the pollution level, and the next one is to obtain the best fitting multiple linear models, and the last one is to validate the multiple regression model using a real study case from the Beijing Municipal Environmental Monitoring Center. Right.
The study focused on the multiple linear regression to predict air quality pollution in Beijing, China. The data from district of Chengping were used as the model, while a few districts such as Wanliu, Dingling, Dongxi, Tiantan, and Guanyuan were utilized as a comparison to the model. The data set was collected from UCI Machine Learning Repository website. This dataset includes hourly air pollutants data from 12 nationally controlled air quality monitoring sites from the Beijing Municipal Environmental Monitoring Center. The scope of study was focused on winter season since, according to the article by AccuWeather, air pollution is worse during winter due to the cold air being denser and has less space between molecules of gas. Pollutants are not free to escape and disperse in the dense colder air. Cold air is denser and moves slower than warm air. This density means that cold air traps the pollution in place for a much longer period and therefore is breathed in at a higher rate during the summer. The time period of this study was from November 2016 until February 2017.
And the significance of this study or this research is, as being said, to forecast and also to protect the public health by providing an early warning against harmful air pollutants, which is also, we can call it as a precaution for human nature to get ready if things are getting worse, or this is our way to get the air condition getting better. And it's also, air pollution calculation is among a demanding task to predict the next day, the next months of air pollution, and the pollution can have a tangible impact on the health, and this is why this kind of research is significant to keep our human nature healthy, I guess, right? And I think that's all from me. For the next part, I will let my other group mates to have their insights on what they're thinking. Thank you. Assalamualaikum.
Next, I will discuss about the evaluation of existing literature review. Literature review is a search and evaluation that provides an overview of current knowledge, allowing us to identify the relevant theory, method, and gaps in this existing research. In this chapter, I will discuss about introduction, linear regression, multiple linear regression, method of air pollution prediction, application of multiple linear regression, and air pollution, variable related to particulate method 2.5. In introduction, the author provides an explanation and overview of what is the purpose of literature review and the flow that she needs to write in this chapter to give understanding to the reader. Linear regression is a basis and commonly used method to predictive analysis technique. It attempts to model of relationship between two variables by fitting a linear equation to observe data to show and predict the relationship between the dependent and independent variable. We can use the formula of equation of y equal to b0 plus b1x plus x to find linear regression, while multiple linear regression is known as multiple regression, which is statistical technique that use several independent variables to predict the outcome of a dependent variable. We can use the formula of MLR, which is yi equal to b0 plus b1 x1 plus b2 x2 plus b3 x3 plus b3 xp plus epsilon I. And there are three common classifications of regression analysis technique to make prediction, which is simple linear regression, multiple regression, and multivariate regression. For method of air pollution prediction, there are many research that are made by the researchers from the past year, which is, for example, from Kumar et al. A study was conducted using differential evaluation with random forest method for air pollution using machine learning. The dataset were collected with daily average consultation for two cities, namely Delhi and Patna, from the Central Pollution Control Board. Also, with Reddy et al., they made a study to aim at forecasting air pollution in the future based on time series data, pollution and meteorology information in Beijing. Machine method by LSTM and recurrent neural network (RNN) were used as a frame for forecasting the air pollution. Same with the Fernando ETAL, View ETAL, and Deliver ETAL. They made a research for method of air pollution prediction. In application of multiple linear regression, a research had made by Paras ETAL. They utilize MR to generate a model for forecasting weather parameter. They divide the rough data into two parts, which if the first part is training data for obtaining regression coefficient, and the second part is test data to check the model. Also, same with the SOSA ETAL, they make a predict to next day early ozone concentration based on feed-forward artificial neural network. ANN using component as input. The implementation of principal component as input has enhanced both model prediction, which is minimize their complexity and eliminating data collinearity. In multiple linear regression, MLR, and air pollution, there are many steps of flow we can use to calculate it. For example, I have made a flow of using MLR in air pollution prediction framework to obtain linear regression equation and flow of using NMR. Lastly, for variable related to particulate method 2.5, variables were selected based on previous study. The concentration of PM10, SO2, NO2, and CO have a significant positive relevance between particulate method 2.5 and significant negative relevance with O3 and temperature. Meteorology factors, namely relative humidity, temperature, wind speed, wind direction, solar radiation, evaporation, precipitation, and air pressure were related to particulate method concentration. It is from ZETAL. From NIETAL, the keyword Beijing air pollution show a high mathematical correlation with particulate method 2.5 concentration between the value of average wind speed, the concentration of CO2 and O3, and PO10, and daily number of microblock entries. Dew point (DEWP) was the most important factor that influenced the particulate method 2.5.
Okay, next is research methodology. I'm person in charge to explain about this chapter and discuss the research methodology that will be used in this study by using multiple linear regression. Okay, there are 7 of them, which are regression analysis, essential for multiple regression, estimation of the model parameters, analysis of variance in multiple regression, have to, which is test for significant of regression, R squared and adjusted R squared. Collinearity model Woodin approach has 3, which is forward selection, backward selection, stepwise selection, and the last one is flowchart of research framework. Okay, first is regression analysis. Regression analysis models the relationship between one or more dependent variable and one or more independent variable. In this research, we study multiple linear regression, which is an extension of simple linear regression. Okay, it is used to predict or explain variation in a quantitative dependent variable based on many independent variables. Okay, multiple regression is categorized which of independent variable or predators explain variation in dependent variable and which others have no values. Okay, this is a multiple regression model which yi represent dependent variable, si is explanatory variable, beta naught is y-intercept constant term, beta p is slope coefficient for each explanatory variable, and epsilon is the model error term also known as the residuals. Okay, that's assumption for multiple regression. There are four of them, which are the error epsilon I are independent, the errors epsilon I are normally distributed, the variance of random errors variance epsilon I equal to sigma square, and the mathematical form for mean of the random variable that exists epsilon I equal to 0. And then the estimation of the model parameters. To estimate the regression coefficient of betas, we are using the method of least square. Thus, to find the least square estimate for beta naught, beta 1 until beta k. We have to solve the simultaneous equation as below. This is simultaneous equation. We need to solve it. Okay. This is step for to solve it. Where we have to let y x beta epsilon until we got this square estimate. Its formula which is beta cap equal to bracket x prime x inverse x prime y, and where s prime s bracket x prime x inverse is the covariant matrix of the least square estimate. Next, analysis of variance in multiple regression. After fitting multiple linear regression model and computing the parameter estimates, is the model a good fit for the data, and are all predictor variables really needed in the model? So the partition of total sum of square into its components, the regression and error sum of square are shown. Okay, look at this formula, which is this summation is SSC mean total sum of square. This is SSR mean regression sum of square, and this is SSE mean error sum of square. Okay, test for significance of regression. This is the test statistic function for this test is based on the sum of square as below. SSR its formula is this one, and SST is its formula is this one, SSE this one. Okay, we put it into another table by dividing 5 columns, which is source, sum of square, degree of freedom, mean square, and f is function. Okay, first is regression. Its sum of square, we call it SSR. Its degree of freedom is k, and its mean square MSR equal to SSR over k. And error SSE, we call it SSE, degree of freedom is n minus bracket k plus 1. Mean squared is MSE equal to SSE over n minus bracket k plus 1. And then the total sum of square is SST, and its degree of freedom is n minus 1. So the test function becomes f equal to MSR over MSE. Then R squared and adjusted R squared. R squared is somehow problematic to measure the quality of the fit for a model because it always shows increment when a regressor is added. It will be difficult to judge whether the addition of new regressor is useful or meaningless. So many users prefer to use adjusted R squared. So its formula is this one. 1 minus SSC over open bracket SSE over bracket n minus bracket k plus 1 over SST over bracket n minus 1, where k is the number of predictors in the current model. SSE over bracket n minus k plus 1 is actually the estimated error variance of the model with k predictors. Okay, adjusted R squared, it will be increased if the new variable is added. So it can be a tool in the arsenal of finding the best model for a given dataset, and also an easy way to guard against overfitting. Uh, and then higher adjusted R squared indicates a better fitting model. The next, collinearity. Collinearity is referred to the condition in which two or more predictors are highly correlated with one another. Collinearity becomes a concern in regression analysis. Where if collinearity is discovered in the regression output, then the interpretation of the model relationships as false should reject until the issue is resolved. Okay, there are three model building approach, which are forward selection, backward selection, and stepwise selection. First, forward selection. It involves starting with no variable in the model, testing the addition of each variable, adding the variable, and repeating the procedure until none improve the model to a statistically significant extent. That's backward selection. It involves starting with all candidates variables, testing the deletion of each variable, deleting the variable, and repeating this process until no further variables can be deleted without a statistically insignificant loss of it. And the last one is stepwise selection, is a combination of the forward and backward selection technique. Okay, the last one is flowchart of research framework. First, we have data collection, and second, sort random data for winter seasons. Third, selection of variable for the model. Then, statistical analysis using SPSS software, and the last one, we validate the results.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, next, my name is Wan Amir Kushari. I will present about analysis and result. For the introduction, this chapter presents the result of multiple regression based on particular method 2.5, which is pollution using data, Beijing Manipulator, Environmental Monitor Center in this chapter. In this study, winter season data were used, which started from November 2016 until February 2017. Okay. For the content, we have first assumption of an R model, second variable selection in multiplicative linear regression, the third accuracy of the model, fourth measurement of the error between the model and data, and the last one is summary. Okay, the first one is for assumption for an R model. In this study, analysis of multiplicative linear regression is based on several assumptions, such as linearity of the data, non-multicollinearity, the value of the residuals are independent, homozygosity of the residual, and the values of the residual are normal distributed. Okay, for the assumption 1, which is linearity, we have two. First is scatter plot, and the second one is correlation coefficient. For the scatter plot was used to see if two variables are related to each other. If the data point made a line from the origin to low x and y value to high x and y value, the data point are positively correlated. If the graph start of the high y value and continue to low y value, then the graph integrate correctly. So we can see in figure 4.1 until 4.8 show the correlation between dependent variable and dependent variable. So for the correlation coefficient, the correlation coefficient was measured on the scale, the value from +1 to 0 to -1. Complete correlation between two variables was expressed by either +1 or -1. When two variables increase, the correlation become positive. Where when decrease, as the order increase, it become negative to complete absence of the correlation or represented by 0. Okay, here you can see 4.1 until 4.7 the scatter plot. Okay, the first one is between PM 2.5 vs PM 10 and others. You can see here. Okay, the correlation coefficient. So the coefficient you can see the left one for the variable particular matter 2.5 and 2.5 and PM10 and O2, CO, O3, SO2, temperature and depth. So the correlation of the variable is here. Coefficient is here. Okay. For the assumption 2, no multiplicator. Okay. Here you can see for the table 4.2 correlation coefficient among the independent variable. Okay. And the table 4.3 we each VI value. This is the result from the data. Okay, for the assumption 3, the value of the residual are independent. Okay, basically the observation are said to independent from one or another or uncorrelated. A rule of thumb is that test the state value in a range of from 1.5 to 2.5 are relative normal. Field 27 suggests that the value under 1 or more than 3 are indefinite cause for concern. The grouping Watson studied where the displayed by many resilient analysis program is not applicable in this situation. Here you can see the hypothesis for the grouping Watson test are H naught which is dw equal to 2, no first order correction, and H1 is 0, which is less than dw and greater than 0 and less than 2, or greater than 2 or less than 4. For first order correction exists. For the first order solution, the lag is 1 time unit. Okay, by using Excel, we get this Rubin minus Watson. Okay, this is the formula, and we get the answer is 2.1164. Okay, next for assumption 4, which is homogeneity of the residual. This assumption states the variation of the error term are symmetric across the value of the independent variable. Homogeneity describes a situation in which is the error term. This is the noise of random dispute in the relation between the independent variable are independent variable. In the same across all the value of independent variable. Okay, you can see here is for the error terms. Okay. Assumption 5. The value of the residual are normal distribute. Okay, if you see here, this is figure 1.9, which is a normal distribute for the residual. Okay, show that the graph is approximately bell shape. Okay, you can see here it look like a bell shape and symmetrical about the mean. This is usually assume normality. So based on the mean value, which is 0.0012, was close to 0, and according to the above figure, the bell shape was symmetric about to 0. Okay, next is variable selection in multiple linear regression. Okay, this is state here when fit a multiple regression model, we use the p-value in the ANOVA table to determine whether the model as a whole of significant for the study backward selection stepwise regression in use. it is to fit a full model and slowly remove term on a time. Okay, starting with the term with the high p-value, remove the term and update the static output, including and the fit static and the p-value for the model terms. Continue this process until only term with p-value. Below, choose the threshold remain. Here we stop removing term when we hit the p-value threshold of 0.5. So we can see here when if the p-value hit to 0.5, we will stop moving. Okay, here you can see the result of table 1.4, which is regression of coefficient, where the p-value here on 0 all. Okay, next is analysis of variance. Here is the ANOVA table. You can see the table 1.5, and this is a hypothesis test of simulation of regression. Okay. Okay, for the R square and A adjust R square, okay, table 0.6, we show regression of statistic. Okay, the correction of coefficient R can be considered as a measure of quality for prediction of the independent variable. For this case, particular method 2.5, a value of the 0.97886 in the example include a level of prediction. Here you can see from based on table from 0.6, we get the R square equal to 1 minus SSE over SST. Okay, so we get the answer equal 0.95816. Okay, this for the from the R square, we get here this 0.9. The independent variable explain 95% of the variability of independent variable. Okay, the adjust function are determined adjust R square can be shown as below correction. You can see here, which is the answer 0.95798. Okay, accuracy of the model. The accuracy of the model include the splitting data across validation and reliability test, which is compare the result of the model calculation with the actual value and correction of the new data to check model predictions. Okay, for the accuracy of the model, we have three. First, we data splitting of the cross relation, and second one reliability test, and the third one check the model prediction with other the relation data. Here this explanation of the three types. Okay, here you can see the from the analysis and we get the result for this table. Next. Okay, so the measurement of error between fit model and the data. Here we continue with the error to find error. To identify the true value of the measurement, the study calculate of the percent of error to get a number that tell how accurate is the prediction. So here from this calculation, we want to check to know the actual value and the accurate of our in this prediction. So how to find the percentage error? First, we measurement t minus actual multiplied by 100 and divide by actual when we get the percent of error. Second, we use the map can be defined by here. This is a formula. Okay, this third one by using RMSE can be defined as like this. Okay, so we get the percentage error for which is percentage we get 9.81%. MIP we get 2.23%, and the RMSE we get 3.56%. Okay, for the summary, as a question, the model of the prediction for the method 2.5 using multiply linear regression has been produced. The built model has been tested and comparing the result between measurement and actual values for different districts in the Beijing. Also, to identify the accuracy of the prediction. The quality of the error has been done. That's all for me. Thank you.
In this study, the recent 2 years monitoring data of Changping, one of the district in Beijing air quality monitoring sites, were used as experimental data, while the variability analyses were conducted between particulate matter 2.5 concentrations and other monitoring elements severally. The result shows that the concentrations of particulate matter 2.5 and PM10, SO2, CO, NO2, O3, temperature and dew point have obvious linear relationship during the same period. Furthermore, the production, formation and changing process of different pollutants were correlated, whereas the formation and change of process existed were interconnected. Therefore, a multiple linear regression calculation model was constructed between the concentrations of particulate matter 2.5 and PM10, SO2, CO, NO2, O3, temperature and dew point. From the equation, it illustrates that for each 1 hour increase of PM10, there is an increment of particulate matter 2.5 of 0.6640, while all other variables are held constant. Similarly, for other variables, when one variable increase or decrease with a certain value, there is an increment or reduction of particulate matter 2.5, while the other variables also will remain constant. After the model was built, it was tested with reserved 30 hours monitoring data. Meanwhile, to verify whether the model is universal, a reliability test has been done for the model with respective 30 hours monitoring data from 5 different districts randomly, with the main conclusions as follows. First, there was significant positive relationship between the concentration of particulate matter 2.5 and PM10, SO2, CO, and O2 and dew point, and significant negative of O3 and temperature. The elements can be used for building particulate matter 2.5 concentration calculation model. From the value of correlation coefficient, the correlation of independent variables with particulate matter 2.5 from large to small were PM10, NO2, CO, dew point, SO2, temperature, and O3. Then, a reliability test was used for the model with reserved Changping data for randomly 30 hours monitoring data. Results show that the particulate matter 2.5 concentration between the model calculation and the actual monitoring was basically consistent, with a good initiative effect, which shows that this model can be used to forecast the particulate matter 2.5 concentration in Changping. Lastly, 5 districts from different parts of Beijing city were selected randomly, while 30 hours monitoring data of particulate matter 2.5 density and other related elements from each district were randomly collected to estimate the results with the particulate matter 2.5 model presented in the study. The results showed that this model was effective for the 5 different districts. Therefore, particulate matter 2.5 concentrations regression calculation model can be widely used for other cities.